Welcome everyone. I am so excited today. We're starting a brand new section, vectors and scalars, and this is such a nice section because it helps explain a lot of science for us, which will hopefully put some things that you sort of knew instinctively into context. So let's get going. So, have you thought about, because this is a big thing now, how a fitness tracker describes your motion during a run? I have a fitness tracker. It tells me I don't do enough, but when I go for a walk, because I don't run, how does it describe the motion for me? How does it describe where I went, where I ended, all of those sort of things? Those all are vectors and scalars. So actually, fitness trackers are very useful. Now, what are we looking at? So we're looking at motion. This whole section is part of motion in one dimension. Today, we're only going to look at vectors and scalars, but there's all of this other stuff to go with it, which we're going to do over the next few lessons. Keywords for today: vector, new term; scalar, new term; magnitude, size. Then we've got direction and resultant. Some of these are new terms. Some of them you may have heard before. Some of them are normal English terms. But we've got a couple there that are new, and it's part of the language of science. Okay, so we've got to make sure we get them down because we're going to use them lots in our science careers. So, and vector addition, I forgot about that one. That's definitely new. That's fun. We like that one. So we're going to look at vectors and scalars, and we can break up vectors and scalars into three specific places. We can look at their definitions, how we represent them, and what the resultant is. So looking at definitions, we're going to need to define what is a vector, and we're going to need to define what is a scalar. And these are physical quantities that have specific properties. So a vector has size and direction. A scalar only has size. Okay? Then we're going to need to look at how we represent them. And we're going to use an arrow, and that arrow has to have size and it has to have direction. You have actually come across this before in your junior years of science. You would have come across it when you've studied forces, okay? We're just now going to take that and put it into another context and give you the real science terms. You probably weren't given it as a vector. You were just told to do certain things, but it was a vector, okay? Then, of course, we have to get to what the resultant is. So we're going to need to define what we mean by resultant, and the key is in the word that it's got result in the middle. Okay, so it's an addition, and we're going to talk about how we can get it. So either we're going to get it by construction. Construction means accurate diagram. So in this section, we need to make sure that we have a ruler where we can clearly see the millimeter marks on it, and it's nice and even. A sharp pencil. We don't like to draw our diagrams in pen. If you do, it's okay, it's not a problem. It's just the tip of our pens tend to be too thick. So our lines can be a little bit off and it can make a big difference. Okay, so we need to make sure we have the correct stationery. And then, of course, we can do it by calculation. Calculation, this is going to look a little different to what you're used to, because we now have to take direction into account. And that's where things can get a little hairy for us, because we're introducing a new way of looking at direction, and we're going to introduce a negative, but it's not the negative like you see on a number line. So when I have a negative number, it doesn't necessarily, well, it's not smaller than the positive number of the value, the same value. So minus 5 in vectors and scalars is not smaller than plus 5. The minus tells me direction for vectors, and I can already see you going, this is hard. It's not. It's nice. We like this. Okay. All right. So let's take a short break. You can think about what we've sort of discussed. And when we come back, we'll do it in lots and lots of detail. So get a glass of water, have a bit of a break, and I'll see you in a couple.